Hello everyone, I'm Ajay, Assistant Professor, Department of Mechanical Engineering. Today we'll see one problem on dimensional analysis using Buckingham's pi theorem. The problem is as follows. The frictional torque T of a disk of diameter d rotating at a speed m in a fluid of viscosity mu and density rho in a turbulent flow is given by T equals d power 5 n square rho 5 into mu divided by d square n into rho. So prove this by the method of dimensions. You can write T is a function of the four independent parameters: diameter, speed, dynamic viscosity and density. Next we will write function of all the variables. So we'll bring T inside. So f1 of T, d, n, mu, rho is equal to 0. So totally there are 5 variables including dependent and independent. So we'll name it as n, which is equal to 5. Next, the value of m, that is m, l and t, that can be found by writing the dimensions of each variable. The torque T is equal to m into L square into T power minus 2. Diameter is L. Speed RPM T power minus 1. Dynamic viscosity m L power minus 1 T power minus 1. And density mass by volume m L power minus 3. So we can say there are 3 fundamental dimensions m, l and t. So the value of m is equal to 3. Now you can write number of pi terms, which is equal to n minus m. So n is the total number of variables, where m is the fundamental dimension. So 5 minus 3, that is equal to 2. So number of pi terms is equal to 2. So now the equation 2, that can be written as f1 of pi 1 comma pi 2 is equal to 0. We'll name it as equation 3. Next, each pi term, it will consist of m plus 1 variables. The value of m is equal to 3. So 3 plus 1, that is equal to 4. And the number of repeating variables will be is equal to m. So there will be 3 repeating variables. Generally, the repeating variables are selected one from geometric property like diameter, length, height, etc. One from the flow property like velocity, acceleration, speed, etc. And one from the fluid property like dynamic viscosity, density, etc. Now in this problem, we can select the geometric property as d and flow property as n and the fluid property as rho. So now we can write these 3 as the repeating variables. So pi 1 term will be equal to d power a1, n power b1, rho power c1, 3 repeating variables, and the fourth term is t. And similarly, pi 2 is equal to d power a2, n power b2, rho power c2, and the next term is, fourth term is dynamic viscosity mu. Now we are supposed to find the values of a1, b1, c1 and a2, b2, c2. First we will consider the first pi term. Now you can write pi, it is a non-dimensional number, it doesn't have any units. You can write m0, l0, t0 for pi 1. d is l power a1 and substitute the values of n, rho and t in the form of mlt. Now to find the values of a, b and c, we'll equate the powers of m, l and t. The power of m, 0 is equal to, so here ml power minus 3 whole power c1. So 1 into c1, here it is 1. So c1 plus 1. So c1 will be equal to minus 1. Power of m, 0 is equal to a1. So here it is minus 3 into c1, minus 3 c1 and 2. So a1 minus 3 1 plus 2. So the value of a1, substitute the value of c1, so we'll get it as minus 5. And the power of t, 0 is equal to minus b1 minus t2. So you can get the value of b1 as minus t2. Now substitute the value of a1, b1, c1 in the pi1 equation, and the negative power, bring it to the denominator. So it will become t divided by d power 5 n square into rho. This is the phi 1 term. Similarly, we will find pi 2 term, equating the power of 0. 0 is equal to c2 plus 1. So c2 will be minus 1. Then power of L, 0 is equal to a2 minus 3c2 minus 1. We will get the value of a2 after substituting the value of c2 in the equation is equal to, so this a2 is equal to minus 2. So a2. Similarly, equating the power of t, will get 0 is equal to minus tb2 or minus b2 minus 1. So b2 is equal to minus 1. Next, you can substitute in the equation pi 2, we'll get mu divided by d square n rho. Now we'll substitute the pi 1 and pi 2 values in the equation 3. So f1 into t by d power 5 n square rho, comma mu by d square n into rho is equal to 0. Now we'll bring this term into the LHS. It will become t by d power 5 n square rho is equal to 5 times the term mu by d square n into rho. Finally, we'll keep the dependent variable t on one side and we'll bring d power 5 n square rho onto the RHS. So this is the final expression, hence proved using Buckingham's pi theorem. So for